stats class in college, even if it's the basic 300 or the 200 level class, you will have some of that style to it. Again, it's not difficult. People think when they get into the stats classes in the college, it's going to be awful. It's formulas. As long as you know how to use your formulas, it's a piece of cake. Yes, ma'am?
My dad's the associate in Henry, and he's saying that a lot of kids, when they get into stats, they think it's going to be like easier or because it's such a low level math class. And he has a lot of kids that end up failing out of it and not introduced to it because
There's a lot of, I mean, it's an involved thing, but it's like any class that you take in which you get into college. Once you get into all right, there are different levels of the stats class. Yeah, I think there's like a 208, which is the lower level one. I want to say it's like a basic 200 level. A lot of people are like, oh, that's going to be easy work, but it's just going to knock you on your butt if you're not ready to do the workload, because there's a lot of work involved in it. When you get to, if any of you are going to get into more of the sciences or the math stuff, you'll be doing like the 350, which is really cool. And then the 470, which is calculus based, which is even cooler. But it's not that it's horribly, horribly scary bad. It's formula. It's nothing but formulas. They're all right there. It's like, oh, okay. Well, let's look at these things. Independent events. We'll talk about those first. Two events are completely independent if the first event has no effect on the second. So if you toss a coin, what's the probability it's going to be a head? All right, if you draw it again, if you flip it again, what's the probability it's a head? If you draw it again, what's the probability it's a head?
0.52. Because one side of the coin is in balance for the other. Blame Mr. Sutherland.
Boo!
Which side's 52?
I don't know.
Wow. That makes sense. Wow. So here's what we're talking about here. If I want to talk about the probability of getting a head, flipping a coin twice, and I want to go probability of a head, then probability of getting a heads again. Your two events that you're talking about here, if they're completely independent, let me rewrite it the way they do. Would be nothing more than the probability of each one of those multiplied together. So the probability of flipping a coin and getting the head
It's 0.25.
and you do it again. So the probability of flipping a coin twice and getting heads twice, 1/4, 25%. Okay. When you start thinking about the improbable winning streak in baseball, if you win 10 games in a row, well, what are the two possible outcomes of a baseball game? Win or lose. So if you win 10 games in a row, it's 1/2, 1/2, 1/2, 1/2.
Could you just take 2 times that to get 1/20?
No. 1, 2, 3, 4, 5, 6, 7, 8. It is. So the probability of winning 10 baseball games in a row, it doesn't seem like it would be that extraordinary to be able to do. But look at it.
It is probably going to be hard.
That's the same when teams are equally matched, though.
It's either win or loss.
I mean, yeah.
Okay.
The boy plays a baby.
I don't know.
Well,
What about the Cubs?
I'm just saying.
Hey!
I'm just saying. If you look at just pure win loss, yes,
Probability.
you're right. And you're right about the whole, okay, there's other factors that go into it. Yes. Think about what the Hawks have to do. The Hawks got to win 3 games in a row. Probability of winning 2 games in a row is 1/4. Probability of winning 3 games in a row then be 1/8. Okay? It's not odds. Odds are different than probabilities. Okay? That's when you start weighing in other factors. We're not going to deal with any odds. Okay? So this is kind of what we're looking at here. It is a wheel. I tried. It's right out of your book here.
Does that spin?
It does not. I can make it spin if you'd like.
Yes.
Yeah, I'm not. Actually, I think the board uses.
Now you need to draw an arrow.
Oh, hold on.
He's not.
It's just the arrow. That's awesome. That's right.
Draw an arrow.
Yeah, but it's just.
So we are spinning the wheel of fortune.
Which way does it go?
Round and round and it goes nowhere. It stops. Nobody knows. All right. So what you want to do here is you're looking at probabilities of what's the probability you get more than $500 on your first spin and then go bankrupt on your second. They're completely independent events. You can't do two spins at once. So you have the probability of a spin greater than 500,
Well, you take all the A's.
and then you want to go bankrupt. So the book had it already marked up about which ones were greater than 500. They marked them at A. So you have 1, 2, 3, 4, 5, 6, 7. Oops. I think there's 8 of them, right?
Round it goes, where it stops. Nobody knows.
There it is.
8. So there's 8 of them out of, I forgot how many are on here. I'm afraid to touch it because I don't want to make it spin again. So what do you have? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10, done counting, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 of them? 24 of them.
24. It's 24.
24?
Yeah.
Oh, that's right, because I didn't count that. So 8 out of 24. And then I want to go bankrupt, and that was 2 out of 24. Again, when you're working with these things, you can just put it right in your calculator with the fraction bars. It'll simplify everything out for you and you're done. What is it?
136.
All right, so let's see what we did. Let's make our.
Oh, okay. I couldn't see that.
It always stops in the same position. Well, I mean, it stops in the same place.
Well, don't tell me that. I know. Yay! $550. Pay up, sucker.
I'll play you blackjack, boy.
Oh my gosh, we're actually doing this? We're actually doing this.
Let's go take this back. Hey, can we all like gather around?
Yeah, let's go
gather around.
I didn't.
All right, here's your card.
Oh, no, we got.
Here's your.
What is that? Yeah, come over. Come over yonder.
Here's your other card.
We have to get it extra.
We gotta like a circle. One man after. There we go. Let's go.
I need a hit.
You need a hit.
We got it. Give me a I understand.
I'll direct the board, don't worry, Mr. Murphy. 20.
I'm broke. And we didn't take. I did make another spinner because it was fun. Anyway.
Wait, what was that?
Rematch.
What was that, Mr. Murphy?
I made another spinner.
Oh.
I was gonna do more probability off, then I realized it didn't really make that big of a deal. How is this the stupid possible thing in the world?
Put numbers on it.
Jason, people program things stupider than
I didn't say
Another idea here is when you're talking about. In this case here, they're talking about Marlins won 5 out of 7 home games and 3 out of 7 away games during the season. During the NLDS, Marlins played the first 2 games at home and the third game away. against the Giants. The Marlins won all 3 of those games. Estimate the probability of this actually happening. So what they did here is they gave you the actual probability, or the actual results of their season series with them throughout the baseball season. At home, they were 5 out of 7. At Giant Stadium, they were 3 out of 7. When they're saying that they won the first 3 games, you have to use the probability then for the home twice, and then the away once. So the probability then would have been 5 out of 7 times 5 out of 7 times 3 out of 7. That gives you your overall probability of this occurring. Yes,
Why do
ma'am?
you use the home twice?
Because they played 2 home games and 1 away game. Okay, that's fine. It's not like you're playing, in Japan. Okay. It's very simplistic when you're looking at independent. When it gets into the dependent, the wording gets a little bit different. So let's look at that.
Wait a second, so it's 75 over 340.
Right, bless you. And then use the actual percent when you get into that. When you get into some of those weird ones, it's kind of tough to quantify what the fraction would look like. You just get
It's
it.
0.22.
Okay, so 22%.
I don't know
Okay.
how you
Dependent. Dependent is a little bit different.
Is that like our replacement?
Yeah. 2 events, A and B, are dependent if the occurrence of one affects the occurrence of the other. The probability that B will occur given that A has occurred is called a conditional probability of B given A is written like that. So when you see this, it means the probability of B given A. That means that A has already occurred. So the probability of B after A has occurred is what that's basically saying to us.
So, what's the difference between does A and then does A's gone now, or is there A still?
There's still an A here, and we'll get into an example here. It's once you do a couple of these, what dependent looks like versus independent, it's not as bad as it looks. Okay, because you've probably done some of these conditional probability, but you didn't realize you were doing that. Like the bags in a marble, probability of getting a blue marble out of 10, whatever, and then you don't put it back in, and your denominators. Correct. It's kind of along those
Like
lines.
cards, what's the
Yes.
not replacing it and then run the point instead?
Correct. So in this case here, what we're going to look at, actually I want to do this one last. I'm going to look at the card one first.
Oh, yeah,
You're going to select 2 cards from a 52 deck. What is the probability that the first card is not a face card and the second card is a face card? First of all, if you replace the card, and then if you don't replace it. So there's 2 parts here. The first part is going to tell whether or not it's going to be, so we're going to say with replacement. And then without replacement. So I want a probability of not face card. And then I want face card. I want that to happen 2 different ways. Okay. I want that to happen 2 different ways. So if I want to find the probability of not a face card, my first pick, how many, remember the complement? Yeah, because there's 12 face cards, so that means there's 40 of them that aren't. Everybody agree on that? Yeah. So that means I'm going to have the 40 out of 52 would be my probability of getting not a face card.
which is 10 out of 13.
Right. I'm not going to worry about simplifying because it doesn't really make that big of a deal here. Now, when I'm going to get, when I put that back in the deck, does the second draw have any bearing from the first draw?
No.
It doesn't. It doesn't have any bearing upon it whatsoever. So now the probability of getting a face card then, the second time around, would just be 12. So in this case, is it an independent or a dependent event?
It's an independent.
It's independent. I was going to write I for independent. Okay. Now, like you were saying, Mr. West, by simplifying your fractions, you want to simplify them before you go. But remember, when you're doing all this multiplying, there's really no need to simplify your fractions because the calculator is going to do it for you. Okay. The calculator does it.
But multiplying is so hard.
30 over 6.
It's so hard.
Sorry, I'll take the calculator away.
It's hard.
Okay. All right, so here's the probability of not a face card.
Not a face card.
Not a face card. I put it back in the deck. Face card.
No.
Now, without replacement, it sounds a little bit different. Not a face card. Again, it's the same value. It's 40 out of 52.
And then it's
I don't put it back in the deck. What has changed in the deck then?
the total.
It's 51. So the total is 51. And that's how that looks. Okay. So what's happening here is that when you have without replacement, that means it doesn't go back into the hopper. It doesn't go back into the scenario. I think back in your algebra classes, you guys probably did a problem that dealt with marbles, where you'd have 3 different colored marbles, maybe 10, 12 of them, and you find the probabilities of getting 2 of them in a row that were the same color without replacement. You probably have done this, and it's very analytical to make sense. Hopefully. Okay. We're just getting started, Lena. We got stuff to look at. So now when we go back and look at how you can get stuff out of a chart, one of the things that I've noticed when you guys were taking the PARC test, there was a ton of charts. There was a ton of information given in charts. So I'm going to start trying. I mean, obviously we only have 4 days left, so it's not like we can do a lot of it, but we'll try and do a couple of things off the chart here. So what I want to do is I want to find the probability that I pick an animal that's listed as a reptile. And then I want to find the probability that the endangered animal is a reptile. Okay? So if I want to find the probability of picking an animal that's a reptile, that means the favorable amount of reptiles is how much?
The favorable amount is
If I want to pick just a reptile, probability of a reptile. Well, how many reptiles are on this table?
Where I guess it's 16.
35 of them. Good.
I'm looking at
So the favorable amount is 35 because here's all the reptiles. Well, how many total are on the chart? Means we got to use. Yeah, I know. It's tough. So what do we have? 59 and 8 is 67. 67.
Don't just add the other.
We just got to add up all of it then. So whatever it is overall.
475.
Thank you.
475.
So the probability of picking a reptile would be 35 over 475, otherwise known as 7 over 95. Yeah. Look at me.
Yeah.
I just made myself happy. Now, the next part is worded again a little bit differently. The probability that the endangered animal is a reptile. So you want to find the probability of the endangered animal given that it is a reptile. Yep. Okay. See how it's worded a little bit differently? The probability that you want endangered given that it's a reptile. Okay. So if you want to do the endangered given that it's a reptile, well, you've got 35 Oh, I'm sorry, the endangered animal is a reptile, so it's a reptile given that it's endangered. It's a reptile. No, did I say that right? Yeah, I was right. Sorry. Endangered, given it's a reptile. It's been a long time since I've done conditional probability. I've seen three sometimes.
355 endangered animals.
So it's 14 out of the 355, because there's only 14 of them that are reptiles. Okay. When you're working with these style things, it just takes a quick second to read it closely to see how the thing's set up. I don't think you're going to have too much of an issue with this, to be honest with you. I'm really avoiding a lot of the permutation combination style. Like I said, there is quite a bit. What's that?
Yeah, exactly.
There you go.
Got mail. You got mail.
Give those a shot, guys. I don't think you'll have too much of an issue. Tomorrow we'll tie everything back together. We'll go back and review all that permutation combination, how that stuff sets up. And we'll test out of chapter 12 then on Friday. Okay?
That's awesome.
Oh wait, you don't have to like.
And if somebody said, I'll take it.